Hello. Okay, so let's go through the 2020 paper. Okay, I won't go through every single thing, but definitely I'll go through the key points and some key mistakes. Okay, for 1B, the arrangement thing, some things to take note. This should not occur. The atoms cannot overlap. It's not referring to bonding here, right? So cannot overlap. Second thing, there cannot be gaps. Gaps. Cannot. Why? This is solid. Solid is closely packed together. Closely packed together means they must be close. So do you need to fill up the whole box? Don't need. As long as you have like what, two rows of 4, make sure they touch each other, more or less circular. I think that's fine. That's basically it. Don't need to fill out the whole thing. If you want to fill out the whole thing, then you can draw bigger if you want to. Yeah, so these are the things that take note. Solid. Closely packed together, orderly arrangement. So closely packed, they must touch. Orderly means very fixed design, I guess. Then if it's liquid is closely packed but not but disorderly. So they must touch, but there's no trend per se. Just touch. That's about it. And for gases, they are far apart. 1, 2, 3, done. So this one quite simple lah. If they test, then take the 3 marks. Okay, for CEC is an issue because why? You all forget about the formula. Ammonia, NH3. Chlorine, Cl2, not Cl. Nitrogen is N2. You should realize that it is a 17 MR, 71 MR, 28 MR, and a 32, 64 MR. So the heavier it is, the slower it diffuses. So therefore it is chlorine, sulfur dioxide, nitrogen, and ammonia. Okay, next RF value. Yeah, so I mentioned before, for separation technique, they love to test either distillation or chromatography. So here is a chromatography question. So let's take a look. Okay, normally all these things here, it will not be given. You have to use actual ruler and measure. Yes. And let's say it's a circular dot. Then of course you measure from the midway point. For example. Yeah, so in this case, RF value. Definitely got RF value one. So in this case, you look at the word acids. So definitely we are looking at more than one. You have 2 dots here. So learn to write statement RF value of X, which is 1.4 over 6, which gives you 0.23. And RF value of Y equal to 3.2 over 6.0 equal to 0.53. You might be wondering, why 2 dP? No, I thought always 3SF. You are right. It's normally you always 3SF. But in this question, look, so many values are given, and these are all in 2 dP. So that suggests that we should give them answer in 2 dP to fit the theme of this question in that sense. And don't stop there, because they say identify the acid. Calculating RF doesn't identify exactly. So you should continue. Oh, this means that there is malic acid. And this means that there is succinic acid. Cool. Okay, next one, B. B is not well done. Because why? A lot of you can tell me, oh, it is more soluble. More soluble than what? So I need you to say that it is more soluble. You don't really know the solvent in this case. So more soluble in the solvent. So what if it's more soluble? What? How does that lead to 0.46? So RF value is basically how far it has traveled over the total solvent front. Right? So N travel further up the chromatogram, which is that paper thing. So it must travel further up the paper or what? It also can, but you cannot just say travel further. Travel further. What do you mean? Pasir Ris to Dover? What do you mean? So travel further up the chromatogram. So this is a quite a standard 1 mark. Okay, this one not an issue at all lah, huh? Isotope very standard, but yet not everybody get the mark. Atoms, same element, same number of proton, and same number of different number of neutron. Simple, easy peasy. Don't waste the mark. This one 2 mark. Take really. Okay, next one. Don't worry, we're not doing A4, A, B, and B. Okay, C. This is a calculation question. So in this case, you can do it in 2 ways. Okay, so the key numbers you can see are 500 cm3 of air. Cool. And you're talking about, so this air has this much nitrogen dioxide. Okay. Then, they say 4.0 times 10 to the power minus 8. 4.0 times 10 to the power minus 8 gram per dm cube. So this is the limit that the question said earlier on. Okay, cool. So in order to calculate and show that it actually honestly does not meet the target. So don't you worry one, because why? We can still do it in terms of mole concept. Equation, mole, ratio, my hashtag hack works. But of course, this is not really an equation. Then we can skip step 1. Step 2, change to mole. So it really depends whether you want to start off with the orange color value and use it to find your red value, or the other way around. Doesn't matter. So for example, let's say I use the red color value to start off lah. So the limit, So the limit tells me this. Okay, so change to mole lah. So in this case, mass of NO2, the limit is 4.0 times 10 to the minus 8 gram per dm cube times the volume. So 4e minus 8 times 500, we get 2 times 10 to the minus 5 gram. Okay, cool, we have gram. Then now we can change to mole. So mole of NO2, the limit is 2 times 10 to the minus 5 times 20. Oops, my mistake. 2 times 10 to the minus 5 divided by 14 plus 2 bracket 32. Oops, 216. So this one divided by 46. Okay, so you get answer of 4.348 times 10 to the minus 7 mole. So notice I leave it as 4 sig fig. The calculator actually says 4.347826087. But save your time, right? All the in-between answers, you leave it as 4 sig fig. Then the final answer of each part, let's say the end of part C, then you leave it to 3 sig fig. If not, you will lose 1 mark for rounding error. Don't waste this kind of silly mistakes and waste your mark. Oh, I have mole. The question is about volume. Okay, then I change to volume. So volume of NO2, the limit again. So I'm finding the limit, which is 4.348 times 10 to the minus 7 times 24 dm cube. I get 1.043 times 10 to the minus 5 dm cube. Oh, okay. So that means the limit is 1.043 10 to the minus 5. But what you actually have is 1.35. So you see, your 1.35 times 10 to the minus 5 is basically the actual. Is greater than the 1.043 times 10 to the minus 5. This is the limit. Therefore, it does not read. So it is technically, it is complicated. I have to say this is a complicated question. But technically, you follow my hashtag hack, it still works. Cool. Okay, next, QA. So QA, you look at it, you more or less have an idea what's happening, right? There are some things here that are quite obvious. First thing, NaOH. Cation test lah. So recall, cation test is either ammonia or NaOH. Why? They must have something in common. And they are both NH3 AQ and NaOH. They are both what we call alkali. Alkali means they both have OH minus ion, which means the PPT formed during cation test is always a hydroxide. Always. So in this case, cation test, I get a dirty green PPT, so this is OH minus. Okay, cool. It makes sense why the hydroxide come from here. Dirty green. From your memory, dirty green means is Fe2 plus. So together, they will be FeOH2, and that is 1 mark. Cool. Then you will be wondering, the OH come from hydroxide, which I added in. Then where the Fe2 plus come from? Here lah, where else? Oh, wow, that's interesting. Okay, next. You see, there is a silver nitrate, which is a anion test. And you remember that this is actually a silver chloride. Oh, that makes sense. The silver is what we add. We always add 1/2 to test if the other half is present. Yeah, then, that means the chloride, where did chloride come from? The chloride must have come from A. Cool. Next. Solution A plus sodium carbonate. A plus carbonate give you CO2. What is this? I recall. Isn't this part of the 5 reaction you learned? Acid plus carbonate? Give you salt plus water plus CO2. So this tells me that my solution A is acid. It is an acid. So this is actually HCl. Interesting. And if it's HCl plus iron 2 oxide, you get FeCl2. Interesting. Interesting. Then what is this colorless solution? This is actually NaCl. So to actually do the question now, look carefully. They say formula. You give me name, then you lose the mark. So when they ask for formula, you give me formula. When they ask for name, you give me name. If they just say identify or something, then up to you, whatever you prefer. So in this case, A is HCl, B is FeCl2, C is FeOH2, D is NaCl, last one is AgCl. Cool. Okay, next one, describe chemical test. When you say describe a chemical test, it's a chemical reaction. And you usually have to also tell me what do you expect to see if this test is really good and it takes place. So this one, you add NaOH solution, aluminium foil, and warm it. Not warm it, warm it. And what do you expect to see? You will have a gas evolved that turns moist red litmus blue. So let me take a short break. So why must the litmus paper be moistened? It's a 2 mark, and I think students generally cannot answer this question. And it's something that I think is quite important. Probably will come out, I guess. I'm not very sure. But it's an important concept. So why? So first and foremost, let's say ammonia lah. Let's say ammonia react and react with what? React with water ah. Moist ma. React with water to form OH minus ion. Huh? So what? Then you tell them lah. Oh, OH minus aqueous ions are responsible for the alkaline properties. So if there is no water, there is no OH minus ions. If there's no OH minus ions, there is no alkaline property. So then the gas would not be alkaline at all. Even if it's NH3, even if it's HCl and you don't be acidic. That's the idea. Okay, next, observation. So this is actually QA. So remember, you must tell me the before and the after color, including what state is it. So a lot of you will just say, oh, purple, 2 colors. Purple what? Purple gas, purple solid, purple vomit. So purple solution turns colorless. So by the way, this is a common oxidizing agent. You are supposed to know the color change. Along with the common reducing agent of Ki. And if it's Ki, we expect it to go from colorless solution turns brown because iodine solution is formed. Okay, question 6. Some of you forget how to do ionic equation already. So ionic equation, my hashtag hack says that we focus on the solid, liquid, gas. Basically everything except the aqueous. Okay, cool. So let me show you how it is done. So I look, zinc. Zinc is not AQ eh. Okay, I copy down, zinc. Okay. CuSO4, AQ. I'm not gonna care about AQ. Next, zinc sulfate, AQ. Who cares? Then copper. Okay, then I'll get copper. So you think, if you are zinc solid, what ion could it become later on? Zinc 2 plus. If you are copper solid at the end, what ion could you actually Cu2 plus? And once you're done writing, right, you actually can see it actually don't come out of thin air. It actually exists, has color coded here. So that is also another way to check. And lastly, check whether it's balanced. Oh, it's balanced. 2 marks. Cool. Okay, for 6A part 2. Question says what? Question says state the element. Means the element lah. So it's actually just 0 plus 2 plus 2, 0. So in this case, I will say that zinc and copper. Okay, question can also phrase it differently. State the substance. So if they ask for substance, they're referring to the entire thing. Means if it's substance, zinc is still the one oxidized, but the one being reduced is copper in the copper sulfate. So we'll say copper sulfate is reduced. If the question asks for state the substance, so it's the entire thing lah. Okay, next one. Standard question. Okay, don't worry about it. I believe that in a normal end of year exam, they should be testing in terms of oxidation state, easier. In terms of electron transfer is very rare and tough. So that means first, in terms of oxidation state. So how do we answer if it's in terms of oxidation state? So you can see here, copper, zinc. Okay, zinc is oxidized. Has the oxidation state increased from 0 in zinc to +2 in zinc sulfate. And that itself is 1 mark. Pretty straightforward. Then copper is reduced. Has the oxidation state decreased from +2 in CuSO4 to 0 in Cu. Yay! Okay, if it's in terms of electron transfer, fine. So even if it's electron transfer, right, I will still use oxidation state to help me figure out what do you mean. So based on oxidation state, zinc is 0 to +2. Okay, I don't care. Zinc is still oxidized. What? That doesn't change. What? It's just the way you explain changes. Okay, so 0 to +2. How many electrons do you think is involved? 2 lah. Then oxidize. Oxidize gain or lose electron? We lose. So all you say is, oh, each zinc lose 2 electron. Oh, cool. Then copper is reduced. Again, +2 to 0. Each Cu2 plus gain 2 electron. That is if they ask you in terms of electron transfer. Okay, this one no worry. Part 4 don't need. Okay, for B is a salt prep question, right? So salt prep question means what? You need to figure out the salt. So zinc chloride is actually soluble. If you are soluble and if you are group 1, you'll be using titration. But if it's soluble and not group 1, not group 1, then we'll be using the excess method. The excess insoluble solid to hot acid. You may remember it as Milo dinosaur. How do you make Milo dinosaur? You take the powder, you spam the powder lah, spam it to hot water. So is you spam the solid to hot acid. Same lah, same. Okay, that's interesting. But so how do I do this? So don't need to worry. It's not new things. It's basically your 5 reactions, isn't it? So you think, what out of the 5 reactions, which one involves an acid? Acid plus metal. You are right. Acid plus base. You are right as well. Acid plus carbonate. So you can choose any of this. So it could be zinc oxide, zinc hydroxide, because base is metal oxide or metal hydroxide, zinc carbonate. So in this case, again, NEMA, so I can use zinc carbonate, zinc oxide, or zinc hydroxide. So all these are viable choices. So part 2, read carefully. Part 2 is not the usual, describe the steps needed to prepare a pure and dry sample of this thing. No leh. Part 2 is just saying, tell me what are the steps you take and explain your steps so that you don't have any excess reactant. So the 2 steps are very simple. Why? First step, add excess zinc. Why? Because this will react with all the HCl acid, which means the 1 reactant gone. Then after that, normally what we do, we filter. Filter for what? Filter is to get rid of the unreacted other reactant. That's it. Okay, cool. Okay, next you have calculation. This kind of calculation question, I can guarantee you is the toughest question of bonding. Energy, but it is guaranteed a test. So don't worry. It's just a matter of bonding. Draw, count. Let's take a look then. Okay, C4H10. 2 of C4H10. They say they give me Okay, sure. Maybe you draw a line like that lah. So left hand side is break bond, then right hand side is form bond. What else do you break? I see oxygen. So you think carefully. Oxygen is group 6. So it has 6 valence electron. Hey, if you have 6, you need to hit the magical number 8. So 6 to 8, you need 2. You need 2 electron. You share 2 electron, you form a double bond. So O, double bond O. And in this case, you need 13 of them. Okay, cool. CO2. So CO2 looks like this. Oh, oops, let me shift it. And I apparently got 8 CO2. Okay, notice, I am very, very intentionally writing these numbers very big. Because so that you don't forget. Sometimes we don't take note of those numbers. Okay, so first step, I'll go ahead and go like, oh, delta H equal to, can I see for myself? What bond am I breaking? Hey, I can see this. I'm breaking C single C. So that means I break 3. So in one of this organic thing, you break 3, but you have 2. So 6 C single C. What else? Hey, you can see C single H. 10 of them. So in one butane, 10. I got 2 butane leh. So plus 20 C single H. What else? You can see here. O double O and 13. So 13 O double O. Cool. So all this is you break the bond. You take in all positive. Then now we're going to form bonds. They are all negative now. So look carefully. Hey, CO2. I got 1 C double bond O, 2 C double bond O. 1 CO2 got 2 bond. I got 8. So minus 16 C double bond O. And next one, water. Water, OH, OH. So 1 water got 2 OH. I got 10 water. 20 OH bond. So I like to write down all the bond, identify the bond. After that, then I just throw in all my numbers. Then lastly, let the calculator do its job. I think that works for me. You can calculate, and I believe that you will get minus 5332 kilojoule. So what I will do next is I'll approximate minus 5330 kJ 3SF. Yes, I understand it's a very nice number, but would it hurt to write an extra line, approximate 3SF? It doesn't hurt. Why not? Yay, 3 marks. Then energy profile diagram. Exothermic. The hum must have hum, yeah. Then next thing, copy Copy what is given, the equation. Oh yeah, I like to copy. Product, copy the product. Cool. Label your EA. Label your delta H. EA delta H is one direction, And if you have the number of delta H, give them the number of delta H, 5332. If units also. That's it, 3 marks. Oh, cool. That's pretty easy. Okay, cool. Alright, next. Okay, don't worry. Question 8 is actually a periodic table question that is technically not tested, but you can still do most of them. The only part of 8 you can't do is 8B. Oh, right, chemical equation. Sure, they say one, They say exposed barium react quickly. Okay, so barium law. Exposed to what? Air. Isn't air oxygen? You get what? BAO law? Lol. Cool. Oh, why are they generally not reactive? Oh, because they have a full valence electron shell. Don't tell me full shell, full eggshell. So if this full shell means what? There is no need to now share electron, give electron, or lose electron. Lose and give electron is ionic Share electron is equivalent. So there's no need to do either of this because it's full, it's happy, it's satisfied. Describe one other reaction. So look carefully at the word here is called chemical property. So it's a chemical reaction. So you can say that, oh, they react with metal, they react with acid to form H2. That definitely works because they are both metals. Metal, acid, H2. Pretty simple. Okay, next. C part 1 is not difficult. It's the phrasing that's the issue. So it is to allow the reacting particles to have enough energy. To have enough energy. What's enough energy then? Equal or more than the EA. You need to, in exam, please spell activation energy. So once you have more than EA, they can actually properly react lah. Okay, next equation. So in this case, you realize this thing is actually what we call a complex ion. Do you need to remember the complex? Don't need. They will give you in that case. They say barium oxide, okay, plus NaOH. Give me this funky looking thing. Okay, and water. So you balance it. Simple equation. Okay, what type of reaction? Isn't BeO a metal? Be is a metal, right? How come metal oxide can react with alkali one? So you think, if it's metal oxide, metal oxide, it could be two. It could be basic oxide. It could be amphoteric. These are the only two possibilities. Amphoteric can react with H+, which is acid. It can also react with OH-. Okay. Whereas basic oxide can only react with acid. Oh, you can see that this is different. So if I have a metal oxide, and this metal oxide can react with alkali to form a salt, I guarantee that this is a amphoteric. And you can see here, your metal oxide, alkali, salt. So therefore, amphoteric oxide. What are other examples? You have three. You're lazy, but remember, lazy but no why. But careful, name. So either you tell me it's lead 2 oxide, zinc oxide, aluminium oxide. Cool, simple, yay. Okay, now we go to section B. Okay, this B9A part 1, horrendously done. So it is about a pair of electrons shared between two non-metal atoms. A lot of you just tell me atoms. You mean metal can have no? Cannot, right? So it's technically non-metal. Dot and cross. Yay! So O, and H. Cross dot, cross, and make sure you show all the valence electron. Equation. How to write the equations here? They very nice. They ready? Give you ready. Why? Just have to read. It's at comprehension. Read the passage and find the relevant information. Okay. So H2O2 give me water, which is H2O and oxygen. Cool. Then we balance it. You realize, simple equation. Yay. Okay, next. Oh, wow. What is this nano thing? Okay, allotrope. We know we have, again, careful, name, diamond, graphite. These are the two common ones that we are familiar with. It has high melting point. So, standard question is here. So first and foremost, covalent bonding. Cannot say compound, Compound, you need to have two different elements. This is just C, basically. So they have a giant molecular structure. So you might be wondering, do you need to say each carbon bonded to three other carbon in this case? Well, are we looking at a property that's explained by that? Are we talking about whether it is a lubricant, whether it's soft? No, right? So you don't need to say that. So next one, a lot of energy. Needed to overcome the many or numerous strong covalent bond between atoms in a giant network of atoms. Therefore, they have very high melting point, in fact. Pretty standard. Next, conduct electricity. So this one you need to describe the structure. So each C bonded to 3 other C, leaving one delocalized electron per carbon atom. Be careful, per carbon atom. It doesn't mean the whole graphite only got 1 electron. Lame. So therefore, they have what we call a C of delocalized electron to carry charges. Conducting electricity is essentially like passing something around only. Carry charges. You can move the charges around, you can conduct lor. That is the idea actually. Oh, okay, cool. Acids. So look carefully, Ka. So apparently we can see that Ka is increasing from here to here. Cause from many decimal to less decimal. So when Ka increase, the pH pretty much decrease. That's it. Lol. 3 mark. Acid, and notice is 2 marks. So you need to give a slightly more longer definition. So it dissociate partially in water to form a low concentration of H+. That's it. Next, use the value to show. Okay, then we show lah. So let's take a look. They very nice. They tell you ethanoic acid. They even bold for you. Sure. So you write down lah. Oh, so the concentration of H+ ions equal to their formula, right? 10 to the power minus 3.37 equal to, okay, let's see, 10 to the power, okay. To the power of minus 3.37. You get 4.266 times 10 to the minus 4, approximate 4.267 times 10 to the minus 4 mole per dm cube. You can't stop here. You didn't really prove anything. You just calculate a number and like, okay. So this is where you write. You say, what do I mean? So weak acid means partially. Then you tell them lah, 0.010 mole per dm cube of ethanoic acid dissociate to form 4.27 times 10 to the minus 4 H+. Clearly it is not a complete dissociation, therefore it's weak. If it's complete, 0.01 will give you 0.01 lah. Complete everything changed. In this case, it's less than that. Proven. Cool. Okay, next. Ionic equation. Again, ionic equation. Do you remember the hashtag hack? Hashtag hack says that solid, liquid, and gas. So if you want, you can actually write a simple chemical equation somewhere first lah. So carbonic acid. Oh no, what's carbonic acid? Oh, they give you the formula. You just have to see H2CO3. Okay, cool. Acid, so it's AQ plus potassium hydroxide, KOHAQ. Oh, acid plus base give you salt and water and salt, so K2CO3. Okay, cool. Hey, okay, so hashtag hack. Hey, H2CO3 AQ. I'm not gonna care. Next one. AQ, don't care. Next one. Water. Okay, I can write down water first. Next one, AQ, who cares? Okay, so water, then think about it. If what ions make up the water? Realize that it is H plus, and you can see that the H plus come from the acid, the OH minus come from the alkali. So you realize it's a 2 is to 2. But with any equations, remember to simplify. So it's just 1 is to 1. Okay, next. So what happens here? Okay. So, well, the question say earlier on already. What did they say? Okay, let me show you. There's the one in red here. It is a monobasic. What is this monobasic thing? Just treat it like HCl. Because monobasic means 1H plus what? So what happens here is this means is technically it's like HCl plus what? KOH. Give you KCl plus water. But instead of HCl, it is now ethanoic acid. So it's like a simple mole concept, isn't it? So this is actually 0.001 mole. And it's 1 to 1. That means this is also 0.001 mole. So you have 0.001 divided by 0.02, 50 cm cube. Cool. There you go. D is your standard question. Salt preparation. So salt preparation, most importantly, is what is the salt? Is it soluble? And you realize in this case this is insoluble. Okay, so this is calcium sulfate. Hey, you remember, if it's insoluble, we are using your precipitation. Precipitation means anyhow whack basically. You just have to have 2 soluble. So definitely you are using calcium something reacts with something sulfate. Then up to you lah. So in this case you can just say, oh, mix calcium chloride solution. Be careful, if you don't write solution cannot. What if you're mixing 2 solids, you see? And sodium solution together until no more solid is formed. So this will be the first step per se lah. Okay, you see 3 mark right for salt preparation usually means 6 steps one. So next thing, once you mix ready, you can filter to obtain the residue, which is calcium sulfate. After you filter, you can wash with what? Water? No, you must wash with distilled water. Lastly, you can dry between pieces of filter paper. Cool. This is pretty easy. I think usually I'll just give 2 marks. Again, but this one very nice. Exam, end of year, first time, give chance, give 3 marks. Yay, and the last question, I believe. Okay, last question, more concept, full more concept, sure. So, excess limiting. Well, first step equation, we have the equation. Yay! Second step, change to mole. Fine, let's change to mole then. So mole of Cl2 is 3.6 over 24, which is 0.15 mole. Cool. Next, I can still find my other mole. Okay, so mole of NaOH. 250 over 1000 times 1.0 equal to 0.25 mole. Cool. But I have my mole of both my reactant at the start. Something is fishy. Something is sus. That's why you need to check whether it's excess. So how do you show your working? You can choose either one of the number and start. So let's say I choose my chlorine lah, chlorine. So I'll write down lor. So 0.15 mole of chlorine. So equation says 1:2. So times 2 lah. So need. So what it need by right what it need? It need 0.3 mole of NaOH for what? For picnic for complete reaction lor. This is what it need for the complete reaction. But your actual mole of NaOH is 0.25. I need 3.3, I have 0.25. So what I have is less than needed, isn't it? So therefore, NaOH not enough lah. It's the limiting reactant lor. Cool. Hashtag hack works So first step equation, second step change to mole is still okay. Third step mole ratio, sure. So to continue calculation, of course we use the one limited. It's like you and your whole bunch of friends go and eat. Of course you will stick to the person that's limited budget, So in this case, we have NaOH. So it's 2 NaOH is to NaOCl, your hypochlorite. Okay, sure. So mole, so third step mole. Oh, okay, I have my mole. Mass. Okay, then change to mass. So it's 23 plus 16 plus 35.5 times 0.125. 9.3125 approximate 9.31 gram 3SF. Yay! Okay, next question. Okay, you have this thing. So how do you test for carbon dioxide? That's a giveaway, right? So you cannot just say, add lime water or something, cannot. So technically, you will bubble the gas evolved into lime water. Then you should tell me what you expect to see as well. Oh, a white precipitate form. Cannot write PPT, PPT is a short form. You will need allowed to write that short form in a practical exam situation. Oh, change to mole again, sure. Times 0.8. 0.0200 mole. Oh, yay. Then what's next? Okay, so what I have now is I have the mole of HCl. The numbers wise, I have not used this number. And that represents the carbonate. Okay. So, 2 HCl 1 XCO3. Okay, so I have my mole of XCO3. 0.01. Hey, I got mass, I got mole, I can find my MR already. 1.92 over 0.01 equal to 192. Oh, okay. So the entire thing is 192. Do you think you can find out the AR of X then? Can. 192 minus 12 minus 3 bracket 16 minus 6 bracket 2 1 plus 16. I believe you should get answer 24. And you take out table. Your periodic table realize is magnesium. Oh, yay. So that's about it. Any questions? Feel free to